Hello, everybody, and welcome to the processes track of the WTF is Cloud Native 2021 conference. We have a bit of a Mad Max visual theme going on here, and I would like to introduce myself. I'm one of your hosts today. My name is Eva Lettner. I'm one of the engineering managers at Container Solutions, and my wonderful co-host is Sibi. Would you introduce yourself?
Thank you, Eva. Thank you so much. I'm also a cloud native engineer at Container Solutions. Today, we're having an amazing list of speakers, and we have Sarah Wells here. Eva will introduce her in a moment, but I'd like to remind you that we have our sponsors booth, and please make sure you visit that place. It will be fun and there will be some swag. And please don't forget to do some networking. Brella has lots of networking opportunities. And do read our code of conduct. We obviously have one. And if you believe you are seeing anything that is not up for this event, please make sure you reach out to us. And yeah, so Eva, could you help me introduce Sarah?
Yes, of course. So our first speaker today is Sarah Wells. She's a tech director for engineering enablement at the Financial Times. And we're very happy to have her here today. She's talking about enabling engineering productivity at the Financial Times. And her favorite thing is cheese. So Sarah, tell us, what is the best cheese in the world?
Honestly, I think saying that you have a favorite cheese would be like saying you have a favorite child. You like them for different reasons. But Vacherin Mont d'Or, which is a French cheese that's wrapped in spruce. It's only available in the winter, and it's just really gooey. It's absolutely delicious, and you can bake it as well. Is very, very good.
That sounds amazing. But now we won't talk about cheese. We will talk about engineering productivity. So take it away, Sarah. We are all very happy to hear it. If people have any questions, please use the Q&A tab on the right side umbrella and ask your questions. And I will be sure to shoot your questions to Sarah after her talk. So enjoy.
Excellent, thank you. So today's talk is about enabling engineering productivity. And I think the key thing that matters for that is to focus on the flow of changes. And I want to spend a bit of time talking about that. The key element that I think matters the most is how long it takes between starting work on a change to having it go live in production. So when I first joined the FT, we released code from our publishing platform and website once a month because we couldn't do it without significant downtime. What that meant is that lots of changes would all go live at the same time. So if a release failed, the first challenge was to work out which release had failed, but also it could be up to 6 weeks since you'd done that work. You no longer had the context in your head of what you were doing. We do a lot more than 12 releases a year now. This shows the changes in production that we've made over 1 month at the Financial Times, and there are lots of them. It's around 2,500 or more than 100 per working day. Every change that we make is small and teams release them at will, which makes it much easier to understand that change, to measure the impact and to roll it back if something went wrong. But I think the main benefit of making lots of small changes and having them go live quickly is that there isn't as huge an investment in trying something out. So Linda Rising says that too many organizations talk about experiments when what they just mean is trying something, because it isn't an experiment unless you have a hypothesis and that you can measure what the impact was and choose to roll it back if it didn't move things the way you wanted. When we were only doing 12 releases a year, so many changes went live at once, it wasn't really possible to measure whether a change had the impact we expected. You couldn't tell which thing might have had the impact. And in any case, it was very hard to roll just one feature back because there were loads of changes made on top of it. And I think the ability to experiment is crucial to being able to deliver true value to your organization. Accelerate by Nicole Forsgren, Jez Humble and Jean Kim looks at what links high-performing technology organizations. That is organizations where the software development department positively impacts the overall performance of the organization in terms of profitability, market share, productivity. And they identify several key metrics that correlate with high performance. So delivery lead time which is the time between committing code to going live, that should be short. There should be frequent releases. So that really means that each change will be small. A low change failure rate, which I think is linked to doing those small changes, because with a small change, you can understand what's the risk of making that change. And then time to restore service, which is how quickly you can fix something if it goes wrong. And that's actually linked to the ability to go from code commit to live quickly, because it tends to be those same automated pipelines that work in both places. What Accelerate also says is teams that manage to do well on their metrics are largely autonomous. Their architectures are loosely coupled. Teams don't have to coordinate with other teams to get things done. So you can release your code when it's ready. You don't have to wait for a scheduled release day. You can spin up servers without having to open a ticket for another team to do that. We often talk about these teams as cross-functional teams because one of the ways you do that is you put all the skills within them. So design, UX, engineers, infrastructure. We talk also about those engineers being full stack, but full stack has to stop somewhere. We can't expect an engineer to know everything from accessibility down to the kernel. Most engineers in our product teams are T-shaped, so they have depth in one part of the stack and they can work in adjacent parts. But a 5-person team can't have expertise in all the things that matter to us, things like accessibility, observability, security, without affecting their ability to deliver value to business. And those teams shouldn't all have to solve the same problems, to have to build their own tools and abstractions to spin up a server, or to buy in their own observability tooling and write things to manage costs and compliance. So that's where a team like my team, Engineering Enablement, comes in. So our aim is to standardize, simplify, and advise, supporting the FT's product development teams so that they can deliver value quickly, securely, and scalably. We provide common platforms and services. Often that means having a relationship with a vendor and putting the thinnest possible layer of tooling in place to make it easy to use a capability. That's something like a log forwarder that makes it easy for people to ship logs to our log aggregation system, or tooling around AWS accounts. We provide expertise and support in areas like observability, cybersecurity, incident management, and we provide insight into what exists. We have a central system registry that tells us what systems we have and which teams run them. And then we can also tell those teams how well their systems are complying with expectations around things like cost and quality. Team Topologies has a lot of great stuff to say about how to structure an organization for flow. And they talk about several different types of team. At the FT, most of our teams are stream aligned. They align to a single valuable stream of work. For example, building and maintaining the FT's paywall or our mobile app. Within Engineering Enablement, we are what Team Topologies refer to as platform and enabling teams. So platform teams focus on enabling other teams to deliver work with substantial autonomy, and they provide internal tools to reduce the cognitive load on teams that are working on business problems. Enabling teams are specialists in particular domains. They have time to research, to dig deep into a domain. They're looking at the future. This gives an overview of some of the things the Engineering Enablement team look after. If we do our job, stream-aligned teams shouldn't have to develop in-depth knowledge within their team on all of these things. They should be able to do what's needed without having to coordinate with another team. The Financial Times adopted microservices and DevOps about 5 years ago. So we've learned a lot about what works and what doesn't when you're building complicated distributed systems and aiming to maximize the flow for your engineers. I'm going to talk about two things that I think have helped us. Firstly, the idea of building guardrails, not fences. We don't want to block people. We want to guide them in the right direction. And the second thing is that we want to add value. So we should look at paving the roads people want to take. But before I talk about those in detail, I want to tell a story. 5 years ago, I was a tech lead for the FT's content publishing platform. We were building a new system using microservices, and we were using FT Platform, which was the FT's first cloud platform built in-house. And FT Platform was the thing that let us even go ahead with building a microservices architecture because of the impact it had on time to provision a server. When I joined in 2011, you probably had to order hardware in for a new project. It took 6 months to get the production server for the first project I worked on. By 2014, you could spin up your own server in minutes, and that is a huge improvement. It's far less than 1% of the time it took a few years earlier, but you needed sudo access to deploy code for the first time to a newly provisioned server. So I could spin up thousands of servers, but I couldn't put code on them. And I understand completely why things were built this way. We were new to doing DevOps, and the infrastructure team didn't necessarily trust the developers with that kind of access. But I think it's about thinking about what your risk is. For me, the cost and the risk comes from spinning up the machines, not from putting code on them. But the other thing is that actually autonomous teams can choose something else. If teams are really autonomous, then they might opt to go out to a third party or build their own thing. And this is a great blog post from one of my colleagues, Matt Chadburn. It's 6 years old, but it's still true. You are providing services, and you have to allow empowered teams to choose something else, but you should be able to build something that's better tailored to their needs, because you aren't trying to build something that suits a lot of different companies. You're building something that's specific for your engineers. So if you can't do better than an off-the-shelf package, then maybe you should think about why you're even thinking about building that thing. So FT platform was good. I mean, it made a real difference in terms of our ability to do things like microservices, or to start thinking about building complicated distributed systems. But it didn't get ahead of changes happening in the organization and in technology as a whole. So apart from that sudo issue, which got fixed, FT platform expected one application per server. With the adoption of microservices at the FT, we had tiny applications. Even the smallest VM had a lot of capacity left over. We wanted to run multiple applications on a VM. And by trying to abstract away the perceived complexity of the cloud, we lost access to useful tools like auto-scaling or load balancer configuration, because the platform was hiding access to those. So teams opted out. One team opted to deploy to Heroku. Using a PaaS takes a lot of complexity away. You have to build some level of tooling, but it's quite quick. The team I was on at the time adopted containers. Being able to deploy multiple applications onto the same server meant we saved 40% on hosting costs. Obviously, you have to think about the other costs. There's a lot of additional complexity of maintaining the platform. But it's sometimes easier to build something than to think about what the opportunity costs are of you having a team working on that platform and building it. Internal teams are service providers now. So you're competing against people who have good documentation and a support structure. So you need to do that well. You need to maintain backwards compatibility, and you need to be very careful about how often you ask people to upgrade stuff. And if you're building a platform, it's a good thing to focus on removing the places where people have to wait for you. There's the concept of a desire path. For example, in a park, you often see a path develop because it reflects where people actually want to go. Ideally, you look out for these desire paths and then you pave them. And at the FT, one thing that happens often is a group or a team or a group start using something and they like it. Other teams adopt it too. If us as a central team, if we can adopt that and make it available to others, we're choosing something that's already been tested, that we know people like. And sometimes it's as simple as taking over the relationship with the vendor. So that's happened for us with tools like Circle CI. Other times we do more. We migrated to Fastly from another CDN provider because a key team started using Fastly. That meant assessing, do we want two providers? Particularly two providers that were for different parts of the estate. So we weren't getting extra resilience, just extra costs and complexity. But it also meant then we needed to decide to do a migration and to build up expertise in Fastly in that central team. So the first aspect of trying to avoid teams waiting is that we try to build guardrails, not fences. The guardrails cover the things we expect a team to consider so that we build things in the right way, but also so that we build the right things. They're there to ensure that things are built, that we build a safe, secure, and operable. They start with a checklist, loosely in the order that you need to tackle things as you build a new product or feature. When you dig into the details, they link out to principles, policies, standards. But I will be honest, very few engineers at the FT will have read these, and they need some work to bring them up to date. What we found is that it's easy to write guardrails, it's hard to maintain them, and it's hard to get people to care about them. But actually, that's fine, because people shouldn't need to read the guardrails. If you're building a system at the FT, the tools should guide you to comply with the guardrails. So for example, BizOps is our internal system registry. We want to know about new systems and about who owns them. When you create a new record for a system in BizOps, you define a unique system code, and you will find it really hard to get something to production without a system code. You need to tag AWS resources with a system code. If you don't, they'll get turned off after a while by an internal tool. You can't use our change API to log a change without a system code. You can't surface the monitoring of the application without a system code. So we are really strongly nudging developers, whatever technology they're using, to make sure that they're entering that information that we care about, rather than saying you should read this and find out why you need to add something to BizOps. So you need to do that to spin up AWS resources. Another approach is to make it easy for people to see how they're doing. We want our critical systems, the ones that need to work 24/7, to have good runbooks, so that anyone who's trying to fix stuff has information about that system. So the runbook should say, here's how you find the logs, here's some troubleshooting for things we've seen happen before, just the information that you would need if you were trying to make things better. So we score our runbooks. We have a set of fields where we know we need information. So if that field has nothing in it, we mark it down. And this worked very well to help us improve our runbooks, particularly when we were starting from a pretty low level of documentation for some systems. And we gamified it a bit. So groups and teams could see how they were doing across all of their systems, and they would work to get above their colleagues in the table. So these are just a few examples, but in general, wherever possible, you should build tools so that engineers are guided to comply with your guardrails and can see how they're doing, rather than asking them to go away and read them. And you should expect your guardrails to change, both because your tech stack changes and the way you build systems changes, and also because your focus is different. So 4 years ago, we were just finishing greenfield builds in 3 big areas of the estate. All of the new areas had used microservices, and we were adopting a DevOps approach at the same time. So lots of our work then focused on working out who owns a service and getting enough documentation to be able to fix things. That's no longer a focus in the same way. In fact, the scoring of runbooks I just talked about is not working as well, because now the problem isn't that runbooks are missing content, it's that the content is incorrect, it's out of date. That is a lot harder to find programmatically. So we're trying to think, well, what can we do to nudge people to have another look at that content? As you change your guardrails, you need to think about how you share those changes as well. They're one of the things that get brought to our tech governance group. And this is how we talk about changes that have a wide impact across engineering at the Financial Times. We meet together. The meeting is open to every engineer. Because we now do this online, it could be 40 or 50 people. There's normally a core group of people who are engaged in discussing the proposal, many more who are there to listen and to learn, and we encourage that. Proposals are sent around well in advance, and people are asked to read and comment on them before the meeting. So the meeting becomes more about sharing the information, formally endorsing the proposal. The consensus work is generally done in advance. The second thing I want to talk about is paving the road. So I think you should expect some diversity in your software estate. If you don't have that, you probably have people forced to use something that isn't a good match for their needs. For some organizations, there's likely a quite standard set of tech for teams to choose between. Even where there is a lot of standardization, there will be some differences. The FT has a very diverse estate for historical reasons. We have given teams a lot of freedom to choose. Paving the road is about making it easy to do the things we need to do a lot of the time, so that, and also providing things that people could just use without a lot of effort, so they're more likely to opt for that option. Internally, we talk about the golden path, an opinionated and supported way of doing things. There's a really good blog post from Spotify. Opinionated means that we make recommendations. There will sometimes be options to choose between. Sometimes it will be a bit stronger than that. If you go off the path, you need to make the same guarantees as those recommended approaches. So you will need to keep these things patched. You will need to support them out of hours, document them, all of that. Supported means that someone owns the capability and will maintain and improve it. We'll be clear on how long it will be around. And if we move to something else, we'll do whatever we can to make that migration simple and painless. And I do want to talk about migrations specifically because if you don't handle these effectively, it can destroy the relationships you have with other teams. In organizations like the FT, where we use microservices and expect teams to manage large parts of their own infrastructure, migrations are a particular challenge because you probably have more things that need to be upgraded. We're probably not using just everything's being stored in a relational database. We probably have a graph database, document stores, lots of other things. And we have lots of separate installations. Every migration hits lots of instances and they're happening more often. And we have lots of places to make changes. If you need to upgrade a library that's used widely in the code base, you may have to do releases for hundreds of services. And that's time consuming without some level of good automation. Recently, we've been documenting our principles for building parts of the Golden Path, and I'm going to go into that in more detail. This is to help us in deciding what to tackle and how. So if we're looking at the things we support, we should be thinking, oh, is this something where we could do more for self-service? For me, every principle that we have developed answers some kind of question we should be asking ourselves. So the first question, and I think it's quite important, is should we provide this capability? There are many things we could be doing. We have to choose between them. What makes this a thing that's worth doing? So we try and look at buying things where we can rather than build from scratch. It's a struggle because engineers like to solve difficult problems and because it's sometimes easier to get an internal team to build something than it is to get the cost approved. But you need to be really careful not to build something that already exists, especially if it's not core to what you as a company do. So if we're going to provide a capability, you might need to make sure it has obvious value to engineers. It needs to be more attractive than the external offerings for whatever it is that you're building. And you need to make sure of that by talking to your customers to find out what they need, but also that you have to make sure you have someone ready to start using the thing you built. If you talk to people and they say, oh yeah, that sounds good, and then you can't find anyone who's willing to adopt it in the next quarter, maybe they're just being polite. So you need to have someone that's ready to use it. The second question is, can people rely that this capability will be around for the long term? And you won't suddenly sting them. I expect anyone who's worked in tech for a while has been hit by something unexpectedly going end of life or requiring a mandatory migration. Companies getting acquired, sunsetting their product, and it applies internally too. If you're building tools for other teams, you do not want to get a reputation for pulling the plug. And if you do have to do that for some reason, you need to provide an alternative and help people move to it. So owned and supported is really important. Usage and cost insights at the moment is mostly important for my group because we don't have an internal market where we charge costs back to individual teams. But we do want to understand two things. Firstly, are people actually using this thing? And secondly, is it costing a lot for a particular team? Because possibly they're using it in a way we didn't expect. And if you can show them that it's costing a lot of money, they can generally fix that up actually. This is a good example of what it means to support a capability. We used to manage DNS via Dyn, which was acquired by Oracle in 2016. And in June 2019, Oracle announced it would shut down the following May. So this was a proposal brought to our tech governance group in October with a plan for migration. So we gave teams 7 months notice. We also took the opportunity to move to an infrastructure as code approach, which meant the migration actually made things better for our customers. And finally, as much as possible, the migration work was done on behalf of teams. The next question is, will teams be able to get on with things, or will they be stuck waiting for us to do something for them? We want teams to be able to find out a capability exists, to be able to find the documentation for the most common use cases. Sometimes teams want to do something complicated. It's fine to cover the 80% of standard stuff automatically and then work with them for the others. And finally, we want there to be nothing stopping them from going ahead. No need for an approval email from their manager or a ticket on a Jira board. There will always be some things that need a little process around them, but the aim should be to keep that as light as possible and to be clear on why. To make things discoverable and documented, we've recently consolidated documentation from a lot of different places into a single place, our tech hub. We want developers to come here first when they have a question about how to do something. It's where the guardrails live, it's where information about our technical capabilities sits. my colleague Reese has been running a poster campaign for the Tech Hub, posted in Slack and put up all around the office. I don't know if people can see, but these are all fake O'Reilly covers saying, you know, where I put Fastly in front of it, how Tech Hub will know. The level of self-service you can offer is going to vary. There's always a case for stepping back and seeing what more you can do. The team that supports DNS at the FT had already introduced infrastructure as code. DNS configuration is held in a GitHub repository and changes are made via pull request. But the team recently ran a survey to see what the pain points were. They got feedback about people having to wait for approvals in that DNS repo. So they did some analysis of the changes. They looked at the last 500 changes made, and they found that many changes looked to be pretty low risk. They were adding something, removing something, or the PR was approved with no comments whatsoever. So they started looking at developing rules to run over any PR to speed things up whenever possible. So some of the rules are, you know, you can automatically approve simple stuff like adding a new record. You can pick up changes that need cybersecurity team to be included, to be involved, and route those approvals to them immediately. You can look for common mistakes, poorly chosen TTLs, incorrect endpoints. You can look for modifications that are benign and auto-approve. And we can look in BizOps, which is our system registry, to find the team member that could peer review instead of waiting for the central teams to do it. And I love this because it's focused on what our customers are asking for, has good and granular appreciation of risk. We've written it up on our product and tech blog, which is public, has a lot of interesting content. We also know, though, that a lot of our audience for these blog posts is internal. So we're telling people about it internally. The next question is, how likely is it that people will get stuck and have to come and ask questions? So we do expect this when people are doing something unique, but if it is something engineers do all the time, they should be able to pick it up easily. We need to make things easy to use. We should aim the documentation for our newest developers, that's juniors or new starters. And wherever possible, we should be consistent with what already exists, so we're not surprising people. This is the documentation for how to set up DNS records. We do want to invest more in how to write good developer documentation. We've done some training in tech writing. We're looking to get advice on how best to structure our tutorials, reference docs, because this stuff is important. Some companies have a consistent approach to building new services. The FT doesn't. As a result, we want people to be able to use our capabilities in ways we didn't expect. We want to have a Unix style philosophy. You know, you have simple, short, clear, modular, extendable code. You can compose things together, pipe the results of one command into another. It's very powerful. And we want to supply APIs and other ways for people to build on top of our tools. One way we're approaching composable capabilities is our serverless blueprints. We use AWS, lots of teams use the serverless framework, and our blueprints are for common needs like reading an item from DynamoDB using Lambda. The final question I want us to answer is, does what we build help people to do the right thing? Defaults should be sensible. We should protect engineers from making mistakes. We should also protect them from accidentally spending a lot of money. If you use our capabilities, you should be confident that they will be kept up to date and vulnerabilities will be patched. And they should be reliable. Reliable is interesting because it depends what relies on this. It means we need to understand our users. An example of that is that there's some nuance. For example, our BizOps system registry is built on a graph of data. Some of the data in that graph is part of our runbook, which we need to be highly available. And ordinarily that would mean being multi-region, but we do not want to support a multi-region graph database. So what we've done is we extract the runbook information periodically and store it in S3, which is highly available across multiple regions. But there's a flaw here too, and one that we found during a production incident. We have put Fastly in front of those S3 buckets, and that uses single sign-on. When we had a problem with single sign-on, we couldn't access BizOps and we couldn't get at the runbooks. So we couldn't find the runbook for the single sign-on system. We now have a zip file of the same information stored in a Google Drive. So we have a backup, and this is something you learn from experience. Central teams get that experience. So here's the full list. Your list may be different, but I think it's good to think about the principles you want to follow and be clear on them. And I hope that this has been interesting. Personally, I really enjoy working in this platform and enabling team area. You have the chance to become an expert in something and the pleasure of building stuff for customers who are right there to get feedback from. If it sounds interesting to you and you're based in London, we have roles available. I'd be very happy to talk to you about them. I want to finish by sharing a couple of really good reads on golden paths, how to approach them, how to focus on the bits that matter, and I'll share my slides later. It's also worth being aware that people are starting to build these platforms. For example, Spotify have built Backstage. If something like that fits with your stack and the way you work, it is likely to save you time and effort. Thank you for listening.
Thank you so much, Sarah. That was very interesting. We took so many notes during the talk. So I just wanted to remind everyone to use the Q&A feature on Brella. That's what we have it for, to ask your questions to Sarah. And I'm going to kick it off with a question that we had while listening to your talk, and that was, how far would you push developing a tool internally before you decide implementing a product, or how is the decision process happening at Financial Times?
Do you mean in terms of what amount of time we spend on internal tooling versus stuff for the website?
Yes.
Well, effectively, the way it works for us is probably pretty similar for the way it works in other companies I've spoken to, which is we have a certain number of people working in the team. So we don't often stop and say, should we move people to the engineering enablement team or away from it? So you have a certain, you're prioritizing within the bounds of what you have in terms of people. I was comparing notes on proportion of engineers working on this internal stuff with a couple of other companies, and it sounds as though 10% of your engineers is not unusual. So Randy Schaup from eBay said it's about 10% for them, but obviously that's a much larger number of engineers than in my organization. And it's around that for us.
Thank you.
I also have a question for you, Sarah. Well, your journey sounds amazing. And from the very first team experimenting with microservices till the first microservice goes to production, how much time did you spend? And I mean, how did it feel?
Ah, interesting. So I don't know so I was on one of the 3 teams that introduced microservices, and I know it took us a few months because we had lots of kind of stuff to be putting together, but also we were still trying to work out what we were going to build as well. So it wasn't that we were, we had loads of ideas about exactly what we were going to do. We were building the framework out while the product side of the group were thinking about what we would be building. There is, unless you're really careful, so there was at the time, this is 5 years ago, there's quite a lot of upfront work. I think there are a lot more tools that are available now for things like that. And I don't know if I would recommend the approach we took of, we're going to build a microservice system and we're going to build, hundreds of microservices. I might have started with let's build something and start removing things when they're obviously their own thing.
Thank you so much, Sarah. I mean, I have lots of questions because in my past work experiences, we've tried this, but we were like a very small group of people, 5 software architects, and it was tough. So kudos to that.
I would say we've been doing things around this area for a long time, and you have to stop and say, is this working? And as you can see, that the original platform we built was great in lots of respects, but it got a few things just not quite right, and people went and found their own things, and it takes a while to get back from that sometimes.
Yeah, totally. Yeah.
I would like to talk to you about documentation because I find it very interesting, and I think everyone in a position as ours has been struggling with documentation, with having a tool for developers, for engineers to go into and dig up exactly what they need. I'm familiar with Backstage from Spotify, and so my question always is, how do you ensure that documentation is written? Who has ownership over documentation, and who takes ownership of it being current and constantly updated? How do you do that at DFT?
I think documentation is very different for a group like ours to, so I've been on like product development teams where you should be doing documentation and maybe you don't do it as much as you should. But a lot of what we're doing is we're providing for other people to use. So if we document it well, then they won't come and ask us a question that we already know the answer of. So the more that we can document something so that it's easy to follow, the more we can be spending our time on higher value and probably more interesting work. So I guess documentation drifts and gets out of date if no one's using it. If it's things that we're actively doing, hopefully people will tell you when it's wrong. And if you respond quickly to those things, then I think that you have to be, if someone says, oh, this bit of the documentation isn't right, the best answer is, oh, you're right. Okay, there's a pull request in, it'll be live in 10 minutes. Because that way people really want to come and tell you about every other thing that you haven't quite got right. So yeah. I think the best way, people don't want to spend ages on documentation, but the more that you can explain that it frees you up for other stuff, the better.
Yeah, thank you. That's a really good point.
Well, and if you're on a product team and you build it, you run it, the documentation is there so that if you get woken up at 2 a.m. to look at some system that you haven't touched in 6 months, what documentation would you want? It's like future you is going to be really pleased if you write down the basics of how you're going to work out why this is broken.
Yeah, you're completely right. We also got a question on our Q&A tab, and that is, you mentioned running an internal survey about pain points. Is this something you do often as an engineering org? Because that sounds like quite an interesting idea.
Yes, we do. I mean, this is actually my group asking. In fact, it's one part of my group asking about one part of what we do. But we do send forms out. We want to talk to people about the things that they find painful. You have to work out how you get a good response for that. We do have to do work to make sure we get a response from engineers at all levels. Because very often when you send out a survey, you get a response from principal engineers and senior engineers, but you don't hear from the junior engineers who are also finding this completely, they find different things difficult. And so you need to look at what's the range of responses we've had. But yeah, we do that. And actually it's quite, generally it can be very straightforward. Here's a form that asks you to rate something on a scale and then with some free text to say anything more about it. So you need to have the option for people to tell you things you didn't even ask about.
Yeah, makes sense. Thank you very much. Thank you so much for your talk, Sarah. It was a very good start of this track. I want to remind everyone to please book some meetings for breaks and meet other people and enjoy the conference. Tweet about us. We have a hashtag, and that is hashtag WTF is Cloud Native. So use that on Twitter, and we will be back in a couple of minutes with our next talk. So stay tuned on this track. See you later. Bye.
Bye. See ya. Bye.